Hello everyone. In this video, we are going to solve rotate least. It is the 14th video on my linked list playlist. So if you are directly jumping to this video, I would highly recommend you to go watch my previous videos where I have been uploading the video from the very beginning so you can build your logic from the scratch. It's on the lead code and the problem is on 61. You can find on the lead code rotate least. So what this problem is a category into medium, but it is super easy. So what this problem is saying, you have given the head of a linked list and you have to right rotate by key places. It means, suppose in example one, where you have to rotate the linked list by two places, right rotate by two places. On the first rotation, my 5 will move to the front. So in the first rotation, my linked list will look like 5, 1, 2, 3, 4. On the second rotation, my 4 will move to the front. So it will look like 4, 5, 1, 2, 3. It basically means rotate, I mean, put the last key element and place them in the front. An example two, you have to left right rotate by keep four places. So on the first go, my two will move to the front, and then again my one will move to the front. On the third go, my zero will move to the front. On the fourth go, my two will move to the front again. So the final linked list will look like 2, 0, 1. So what will be the extremely brute force that will be coming into my mind? What we are doing in every iteration, I'm moving the last element to the front, right? So if I do this by key times, in example one, in the first go I move 5 to the front, in the second go I move 4 to the front, means the last element to the front. So that will be brute force. Let me explain it into detail. So suppose what I will do, I will put a temp to the front and I will move my temp to the last node. uh, that will while my temp next node equals null, I'll keep moving my temp, and finally my temp will reach it here. So what I will do, I will say simply temp next, can you point to the first node? That will be the head. So my temp next should be pointing to the head. After that, I will see head, can you be my temp, my head will become to the temp. This was the temp. So I will say temp head, can you become temp? So my new head will be the temp, and I will break this link. To break this link, I need one more pointer, which will be pointing to the previous node of the temp. So I will take one more node ref, which will point to the null initially, and I will keep moving them. My pref pointer and temp pointer, I will moving them simultaneously. So my temp will be pointing here, my pref will be pointing here. After that, I will say temp, your next should be head, and I will break this link. And I will say head, can you become the temp of next? Again, I will do the same thing. Again, I will do the same thing. My temp will point to the head. So my new head will become this one, 4. So our final linked list will look like 4, 5, 1, 2, 3. That will have brute force. What we are doing, we are uh, we are every time for k, we are we are doing it by k times, and every time I'm traversing a linked list to find the last node and pointing into the head. So my time complexity will be around k into n because I am doing this operation k times, and every time I'm traversing a linked list from the first node to the last node to finding the last node and pointing to the head. So it's around k into n, which will be the a very big. So can we optimize it? Yeah, we can optimize it. But how? Suppose if I make it a cyclic, okay, I created a cyclic link list. I just made a cyclic link list. After that, on a second go, I will break this link. This will be n minus k. Suppose there are 5 nodes and you have to rotate by 2 times. So you just have to break this node, that will be 5 minus 3. So somehow if I reach this node, that will be the 5 minus 2, that is 3. On the third node, I can simply break this link, and I will point my head to this node, and will it look like? the final answer. Yeah, it will be. So how we will do it? First, again, I will put the temp here. I will go to the last index, so my temp will be pointing somewhere here. After that, I will say temp next can you point to the head. So my temp next is pointing to the head. Again, okay. So now on the first time we have created a cyclic linked list. And after that, what we need to do is there will be a arrow in the city. Just give me a second. There will be an error. Why arrow is not clear? Okay, so there will be an arrow in the city. Okay, so our cyclic linked list has been created. Then what we need to do is I have to reach to this node. If somehow I reach this node, I can simply break this link. Now I point my new head to this node. Our final answer will be looking like the exact same. Okay. So how can we reach it? Suppose there are five nodes and you have to reverse it by two times, two places. So this node will be the 5 minus 2. It will be the third node, right? Yeah, exactly. So if you minus 5 minus length minus k, you can reach here. Then again traverse in this I mean linked list, and after when you reach here, pointer head here, and after that you can simply delete this node. No, not node. You have to delete this pointer, next pointer. It will be pointing to a null. So after that you can see your answer. So let's move to the LeetCode editor and try to code it up. So what we need? First we need length. Let me create the length, which will let's suppose one English. And after that, what we need? We have to find the length. So let me create the least node temp because I'm doing the same thing into one. It will point into the head. After that, I have to traverse in a linked list. So I will say my while my temp next is not equal to null. I will keep traversing in my linked list. And what I will do, I will say my length plus plus because I have to find the length. And I have to move my temp to the last node, right? If you remember. So I will say temp can you move to the next. So it will be moved to next. Okay. So we got our length and our temp will be pointed to the last node. After that, what we need to do, we have to create the cyclic list. So how we will create it? I will simply say temp can you next point to the head. So it will create a circular linked list. After that, what we need to do? You need to do one more thing that will be k equals to k modulo len. I will tell you why. Suppose, let me tell you about this thing first. Suppose my k equals to 4. Okay. Do we need to, uh, I mean, right rotate it by 4 places? Because if we say on a third rotation, it will be exactly like the first one. So, do we need to rotate it by 4 places? I don't think so. If even if you rotate it by one place, even if you rotate by one place, the answer will be exactly like the our original answer. So that's why I am then doing the modulo. There was a linked list of three sides. If I modulo 4 with a 3, that will be giving us 1. And if we rotate it by 1, it will give the same answer, right? So that's why I am doing it modulo. Suppose if our k equals to like 1000 or 2000 or more, probably more than that, we don't have to rotate it by that much place if our length is smaller. So okay. After that, what we need to do? I have to find my remaining. So let's call it remain equals to length, length minus key. Okay. So in this case, if my length is equals to 5, you can directly see 3. So I have to go to 3 node. How I will reach here? So I will simply say I have to traverse in the while loop again 3 times, but this time ramp time. So I will simply say temp time, and let's keep decreasing it. And in this thing, what I need to do is temp, can you move to next? So my temp will move to its next. After that, my temp will be pointed to the 3 node. After that, what I need to do? I have to make it add to the next. So my new head will be what? Next of temp. And I have to break this link if you remember. So I will say temp next. Can you point to the null? PTR. After that, I can simply return my head. Simply return head. And if I run it, it should be working. Let's say head. Where is head? Not double D. And anything else there's error. Line number 13, line 13. Okay. Okay, so it's running. In the Java solution, it will be the exactly same, but okay. Runtime error. Just give me those. Okay, so my linked list can be null with a zero node or one node. So you have to put that extra condition. What if my linked list is, what if my there's nothing in a linked list? So if my head equal null, or if there's a one element in a linked list, you don't have to reverse. I mean, you don't have to do anything. So if there is a one node, or if there is a zero node, and there will be one more condition. What if my k equals to zero? If my k equals to zero, you don't have to rotate it. So you can simply return head. You can simply return head, not head. Return head. Now it should be working. Let's submit it. The Java, I will copy the exact solution. Let's move to the Java, and I will paste the whole thing. And in place of null, you can simply say null, and this will be dot temp.next. Anything else we need to change? Temp.next. It will be C++ and Java are almost same in many ways. So now it should be working. After that, let's move to the Python. There's one more thing you have to say. Should if they are null and my head next equal to null. Anything else while it's not equal to null. Now I think it should be working. While my RAM minus minus. While my RAM greater than 0, RAM minus minus, remaining minus minus. Let's submit it up and let's move to the Python solution. For the Python solution, can I copy the whole thing? Let's copy it. After that, we will see what we need to do. So in a Python, if I paste the whole thing, it will say a couple of error. But don't worry, guys, don't worry. If my head, or you can simply write or k equal 0. You don't have to write null, or you can. It's all up to you. Return the head. Okay. In len, there's various thing you need to change. Give me just a couple of time. Okay, so I think this should be working. I have written the whole exact code, but it's not returning anything. Okay, so if not had, because had should if my head is null, and if there's one element, you have to return the head. You can simply return head. So I think it should be working, but it's not working because where I have Null, null. Oh, in Python it's not null, it's none. None other than none. Now let's run it. Okay. So what will be the time complexity? We are running one loop to finding the length and making the attempt to point to the last element. So big of n. After that, we are again running a loop to length minus k. So it will be around n minus k. So the whole time complexity will be around 2n minus k, which will be log of n. I mean not log of n, big of n. And we are not using any extra space. So the space complexity should be 1. So I hope you like this video. If you like, hit the subscribe button, hit the like button. And if you have some queries, comment below.